Hello everyone, there is group 5. Today we want to talk about which financial indicator is most closely related to corporate bankruptcy. To answer this question, we need to find a dataset. We find our dataset from S&P Global Market Intelligence. That's one software that provides financial information and analysis. We set the period from January 31st, 2002 to December 31st, 2014, and select 34,530 annual financial information of different companies randomly. This dataset contains 34,530 rows and 29 columns. These columns can be divided into 4 categories. GVK is the serial number and CONM is the company name. These 2 columns belong to index. Data date belongs to date and bankruptcy belongs to categorical. Other belong to numerical. As for why we choose this dataset, first, the dataset is large enough. It has 34,530 pieces of data covering thousands of companies. Enough samples are the basis of research and analysis. Secondly, this data contains the key data we need to calculate ROA, ROE, data rate, and other financial data and analyze the company's financial situation. We need to know the company's net income, total asset, total debt, and other information. These are included in this dataset. Next page.
Then I will talk about the part of data preparations and cleaning. Based on the problem statement, the categorical column, bankruptcy, will be the target column, which is a binary variable. If a company was bankrupt, the bankruptcy variable equals 1, otherwise it equals 0. Firstly, we check the percentage of bankruptcy case and the non-bankruptcy case in total observation. We find that the bankruptcy case is only 0.62% and the non-bankruptcy case is 99.38%, which is seriously unbalanced. Next page, please. Secondly, we drop some unreasonable observation, which cells are 0, or the difference between the total assets and total liability is 0. Then we add 10 financial indicators variable, which are useful to predict whether the company is bankrupt, including return on asset, debt ratio, and so on. Besides, we drop the columns of company key, SQL, date, and company name, which are unique to our prediction. Next page, please. After that, there are a total 44 variables. We draw the distribution histogram and correlation plot of variable. Next page, please. Then we draw the box plot of 10 financial indicator variable that we add before. Next page. In the following, we remove the outlier observations that 10 financial indicators variable are smaller than the 25th percentile minus the 1.5 times interquartile, or larger than the 75th percentile plus the 1.5 times interquartile. Then we draw the box plot and histogram plots again. Next page, please.
Okay, in part 2, we will introduce the assembler methods and also the workflow. On next page. Before training a model, we input features. For the same feature, the values in different samples may differ greatly, and if the distribution of data is very scattered, it will also affect the training results. At this point, we can use standard scalar to normalize the values in the features. That is to a normal distribution with the mean of 0 and the variance of 1. Random oversampler is to randomly sample a small number of categories and then add the samples to the dataset to achieve category balance. In our case, setting sampling strategy equal to 1 issues that the few classes are oversampled to the number that equals to the number of majority classes. Next page. Then we choose grid search to be the tuning method. It works by looping through all the possible alternatives, and the best parameter is the final result. However, the final performance of this method has a great relationship with the partition result of initial data. In order to deal with this situation, we adopt the way of cross-validation to reduce the contingency. The common disadvantage of grid search are time-consuming. The more parameters, the longer it takes. Therefore, under normal circumstances, first set a large range and then refine. This figure clearly shows the overview of the process of parameter selection and model evaluation with grid search CV. Next. In part 3, we will show the results of the 3 models we choose, including logistic regression, random forest, and gradient-boosted decision tree. Next. Logistic regression is the preferred method for classification. It predicts the probability of future results based on the representation of historical data. The advantages are simple and easy to explain. It is very suitable for large-scale data, but it is easy to fail to fit. Before we tune in the model, the accuracy is only 0.87. The model validation result shows that almost all the indicators decreased after tuning, other than the area on the ROC curve value increased slightly. Next. Random forest introduces 2 random quantities. Firstly, to randomly extract sample data from the training set. Secondly, featured attributes are randomly selected as candidates, stability attributes in the process of building decision tree. Because of the 2 random quantities, the random forest is insensitive to noise and overcomes the problem of overfitting. Through different parameter combination using grid search, the accuracy of the model improved a lot. The area on the ROC curve value also increased to 99%. Next.
So one of the major drawbacks of the decision tree is that they always overfit the training data, and the gradient-boosted classifier is one of the most useful ways to solve this problem. Gradient-boosted classifier is used to construct a more powerful model by merging multiple decision trees, which can be used for both regression and classification. Unlike the random forest approach, gradient boosting uses a sequential approach to constructing trees, where each tree seeks to correct the error from the previous one. Here we still use grid search as a method of model tuning. Among all the candidate parameter choices, the best performing parameter is the final result by iterating through the loop and trying every possibility. In this model, through different parameter permutation and combinations, the best result is finally selected as max iteration equals to 20, max step equals to 10, and max bin equals to 10. However, the disadvantage of this tuning method is that it takes slightly longer time to learn. According to the result of this model, the F1 score of this model reached 0.97, which is higher than that of random forest model with F1 equals to 0.92. After tuning using grid search, the F1 score of this model is even as high as 0.99. The area under ROC curve value is 0.9927 in the original model, and then it increased to 0.9983 after tuning, which indicates that our model could almost perfectly distinguish between the bankruptcy and non-bankruptcy companies. It can also be proved that the classification accuracy of this model is greatly improved by effective parameter tuning. Next part, please.
In research, we use logistic regression, random forest, and gradient-boosted classifier to solve the classification problem of whether a company is bankrupt. We introduced the calculation of financial indicators in the data processing stage. Since the relatively large differences in absolute values, such as revenue and total assets in the original financial reporting data, calculating financial ratios helps us to standardize the scale of the data and facilitates comparison and further analysis. Due to the highly unbalanced nature of our raw data, we use oversampling method to mitigate the class imbalance problem. According to the feature importance analysis, the top 5 important features are pre-tax income, Altman X4 Z-score, net income, ROA, and net income margin. It indicates that profitability is an important consideration when determining whether an enterprise is at risk of bankruptcy. From the comprehensive evaluation of accuracy, precision, area under ROC curve, and F1 score, the gradient boosted classifier model has the best prediction performance, followed by random forest model and then logistic regression model. For model improvement, we use grid search to find the optimal parameters. Our research proved that choosing the right parameters can help improve the performance and classification accuracy. In conclusion, our project model is capable of accurately classifying whether a company is at risk of bankruptcy based on its financial situation. And it can also provide some insights to investors in screening investment targets in the financial market and forecasting the risk of company bankruptcy. That's all for our presentation. Thank you.